Today we will talk about the origin of magnetic moment. Origin of magnetic moment. So first of all, we have to learn about this thing. What is magnetic moment? It is a measure of the magnetic strength of a material. Magnetic moment is nothing but a measure of magnetic strength of a material. Then we will talk about the origin of, as the topic is the origin of magnetic moment. So there are fundamental two types of magnetic moment, two types of origins, and that rest are the derived types. The first one is the orbital motion. Motion of electrons and its magnetic moment. When an electron is revolving around the nucleus, then it is producing a charge. It is producing a current, not charge, it is producing a current. That current we say that is I, and current is nothing but charge per unit time. This is the formula for current. So charge is, what is charge? What here will be charge? It is the electron, the charge on an electron. Right. As the direction of the electron is negative to that of the direction of flow of current, so we give the minus sign. If we consider the magnitude only, it would be by t, and the t would be time period. Time period means the time needed for electron to complete one revolution. For this, t equals to 2 pi by omega. Omega is the angular frequency. Then the magnetic moment due to the orbital motion, we denote it by UL, would be current per unit area. We got the current part, that is 2, that is E by 2 pi into omega. How we get it? By putting the values to the first equation. We name it equation 1. Equation 1 I equals to Q. Q is E. Q is 2 pi omega. Then what would be the area? Area would be the area of a circle. It is pi r square. Pi would cancel out. That would be E omega r square by 2. Now from classical mechanics, what we know from classical mechanics, when an electron is revolving, any particle is revolving, then any particle is revolving around the center. The distance from the center to the particle is r. We call it the radius vector r, and the particle has a velocity v, and there will be an angular momentum L, which equals r cross p, where p is the linear momentum. times of v. V is the velocity. Okay, as we have seen that r, the radius vector, is perpendicular to velocity. Suppose the particle is here, radius vector will be here and the velocity will be here. It always makes 90-degree angle. Then r will be sine theta, and theta would be 90 degrees. Sine, the value of sine 90 is 1. Then that will r and v. Now v, suppose I am considering a 2D circle. Circles are generally 2 dimensions, spheres are 3 dimensions. Say from point A to point B, a particle has moved and made an angle theta. So if it's d theta, then it would be theta plus of d theta, and it has a radius, say r, and the distance traveled is nothing but say ds. So ds would be nothing but r times of d theta. Okay, and velocity, what is velocity? V equal to ds by dt. From s, that is displacement, we get d dt of r times of d theta. R is constant, r would come out d theta by dt. Then angular frequency, so angular velocity would be omega equals to d theta by dt. Then the relation v equals to r omega. V equals to r omega would come. If I put v equals to r omega here, r square m omega. From here, if we calculate omega equal to L by m r square, if I put this in equation number 2, I would get mu L, that is the magnetic moment for the orbital motion, equals to E r square by 2 into L times of m r square. Now if I consider the direction also, then it will be a negative sign. R square and r square both would cancel. Minus of E by twice m L. Now from Bohr's atomic model, so what does the Bohr's atomic model say? He made not a postulate but a conclusion that an electron which is in a circular orbit, say an electron is revolving around a circular orbit, has quantized angular momentum. The angular momentum L of the electron would always be quantized, nh by 2 pi, and L denotes the quantum number. Many people denote this with L. These are eventually the same thing. What L? We got L equals to mvr. We can put it here or directly. L equals to nh by 2 pi. Many people denote this N with L. So in many books also it is written from Bohr's atomic model. And Bohr said that an electron which is revolving in a circular orbit has quantized angular momentum. The angular momentum is quantized. So L would be LH by 2 pi. Then mu L equal to minus of E H by 4 m pi L. L equals to mu b times of time, where mu b means Bohr magneton. It is the fundamental unit of magnetic moment. So we get that when we get this term Bohr magneton, we can verify that magnetic moment is there. Next we will discuss the second case, that is due to spin, how the spin of electrons how does the spin of electrons generates magnetic moment. We'll discuss it in the second part.